Hey, all right, welcome to the Homework Solutions for Section 5.4a in AP Calculus. We're on page 344, and we're going to be going over these problems. I was able to get quite a few on the board. Just to remind you, the derivative of e to the x is just e to the x. And e to the natural log of a equals a. E and natural log cancel each other out. And then the natural log of e is equal to 1. So those are some things to remember. For number 1, we are supposed to write the exponential equation as a logarithmic equation or vice versa. All right, so for number 1, what I'm going to do to get it into a logarithmic equation is take the natural log of both sides. So we have natural log of e to the 0 is equal to the natural log of 1. And then if I pull that 0 out front as a coefficient, I'd have 0 times the natural log of e, which is 0, is equal to the natural log of 1. And we know that's true. The natural log of 1 is equal to 0. So number 3, I have a natural log of 2 is equal to 0.6931. So what I'm going to do is exponentiate both sides, because you can take the exponents of the same base and set them equal to each other. So e to the natural log of 2 is equal to e to the 0.6931. That's the exact same equation. Now we'll use the properties of logs. The e and the natural log cancel each other out, just like up here. So we'd have 2 is equal to e to the 0.6931. You can check that in your calculator and see that that is true. Number 5, e to the natural log of x equals 4. We want to solve for x. E and natural log cancel each other out there, so we just have x equals 4. Number 7, the natural log of x equals 2. Let's exponentiate both sides. So e to the natural log of x is equal to e squared. E and natural log cancel each other, so we have x is equal to e squared. All right, now we'll get into taking derivatives. So number 29, we have f of x is equal to e to the 2x. So the derivative would be e to the 2x times the derivative of the exponent. So think of that as a chain rule. It's kind of like times the derivative of the blob. So it's e to the 2x times the derivative of 2x, which is 2. So that'd be 2e to the 2x. 31, we have y is equal to e to the minus 2x plus x squared. So that's going to be e to the minus 2x plus x squared times the derivative of the exponent, which would be negative 2 plus 2x. Let's clean that up. The book likes to put the positive first, so this is the same as 2x minus 2. I'm bringing that out front, and then times e to the minus 2x plus x squared. All right, number 33, we have y is equal to e to the root x. So y prime would be e to the root x times the derivative of root x, which would be 1/2 x to the minus 1/2, which is the same as 1 over 2 root x. So cleaning that up, we'd have e to the root x on top, and then making that negative exponent positive over 2 root x. If you wrote 2x to the 1/2, that's also fine. All right, 35, g of t is e to the minus t plus e to the t all cubed. This is a chain rule. Let's bring that 3 out front times what's within parentheses to the second power, and then times the derivative of the inner function. So that would be e to the minus t times negative 1, because the derivative of negative t is negative 1, plus e to the t. All right, so cleaning that up, we would have 3 times this, e to the minus t plus e to the t squared, times e to the minus e to the minus t, because of that negative 1, minus e plus e to the t. And I believe the book reverses these two and makes it e to the t minus e to the minus t. No problem. Either way is fine. And then 37, we have y is equal to the natural log of e to the x squared. The easiest thing to do is to bring that x squared as a coefficient out front. And then you have x squared times the natural log of e. You know the natural log of e is just 1. So y is equal to x squared. Y prime then would be 2x. So it'll save you a lot of work if you just rewrite. All right, that was all the pretty easy ones. I was able to smush all that onto the board. So now let's... I probably shouldn't have erased that, but that's okay. Now let's go to number 39. So number 39, we have y is equal to the natural log of 1 plus e to the 2x. So y prime, remember the derivatives of natural log is 1 over the blob times the derivative of that inner function. Well, that's going to be e to the 2x times 2. Because the times the derivative of 2x. So cleaning that up, we would have 2e to the 2x on top over 1 plus e to the 2x on bottom. All right, nice. 41. Now things start to get a little fancier. We would have y is equal to 2 over e to the x plus e to the minus x. Here's what I would suggest doing. So you can do this as a quotient rule, but I would rather make it a chain rule because on top, I don't have an x, I just have a coefficient. So this is the same as 2 times e to the x plus e to the minus x to the negative 1 power. Now I can use a chain rule. So y prime, bring that negative 1, multiply it by the 2, so we've got negative 2 times e to the x plus e to the minus x, then subtract 1, so to the negative 2 power, and then times the derivative of the inner function, which would be e to the x, and then e to the minus x times negative 1. So that's going to be minus e to the minus x. So again, e to the minus x times the derivative of the exponent, negative 1. That makes this a minus. So what that does is that the negative 2 stays on top. So you've got negative 2 times e to the x minus e to the minus x over, and then we're going to make that negative 2 to a positive 2, so let's bring it downstairs. All square. So that's the way I would want to see it on a test. Make sure you make that negative exponent positive. Okay, let's see if we can fit 43 on here. So 43, we have y is equal to x squared times e to the x minus 2x e to the x plus 2e to the x. So this is a lot of product rule here. So y prime. First, x squared times the derivative of the second, so that's just e to the x, plus the second, e to the x, I'm leaving a little space here, the second times the derivative of the first. I want to put it out front. So that's the derivative of this. Minus, now I'm going to put all this in parentheses. The first, 2x, times the derivative of e to the x, which is just e to the x, plus the second, e to the x, I'm leaving a little space in front, times the derivative of 2x, that's just 2. And I put parentheses around it so we don't mess up that minus sign. And the derivative of 2e to the x is just going to be 2e to the x, because the derivative of e to the x is e to the x. So I've got x squared e to the x, and then the 2x e to the x minus 2x e to the x, that cancels. And then you'd have minus 2e to the x plus 2e to the x. See, minus 2e to the x plus 2e to the x, those cancel. And so everything's cancels except this first term. So that's all you're left with. And I would want to see that on a test. I would want you to recognize that you can't combine like terms and cancel a lot of that. All right, we are cooking. Let's go to 45. So 45, we have f of x is equal to e to the minus x times the natural log of x. This will be a product rule. So it's the first, e to the minus x times the derivative of the natural log of x, that's 1 over x, plus the second natural log of x times the derivative of the first, which would be e to the minus x times negative 1. So that's times minus e to the minus x. So this is going to be e to the minus x over x minus, because it's a minus, right? So minus e to the minus x natural log of x. That's really the best way to write it, so that you don't think the e to the minus x is part of the natural log. All right. Let's see if we can fit 47 on here. So I've got y is equal to e to the x times sine x plus cosine x. Okay, another product rule. Seen a lot of product rules today. It's the first, e to the x times the derivative of the second. That'd be cosine x. Derivative of cosine is minus sine x. Plus the second, sine x plus cosine x times the derivative of the first, e to the x. Now you might be tempted to stop there, but if we distribute these e to the x's, some stuff cancels out. So if I would have e to the x cosine x minus e to the x sine x plus e to the x sine x, I hope you see what just happened there, plus e to the x cosine x. So I just distributed the e to the x's. So the minus e to the x sine x and plus e to the x sine x cancels, and then we would just have e to the x cosine x plus e to the x cosine x. That's 2 e to the x cosine x. It's 2 of them. So we can just write a 2 out front. And that's the best way to write that solution. Okay, almost done. We just need to do the word problem. So number 66 is a problem about depreciation. We have V is equal to 15,000 times e to the minus 0.6286 t. Okay, and the question, first it says graph the function. Not going to go over that. Hopefully you did that in your calculator, but I want to do B and C on the board here. All right, so it says find the rate of change when t equals 1 and t equals 5. All right, so really that's what we're doing here. So dv dt, we're taking the derivative, that gives us the rate of change, right, is going to be 15,000 e to the minus 0.6286 t times the derivative of negative 0.6286 t, so times negative 0.6286. So if we multiply 15,000 times negative 0.6286, that's going to be negative 9429 e to the minus 0.6286 t. So let's find v prime of 1. That's negative 9429 times e to the minus 0.6286 times 1. You can just plug that right into your calculator, and you'll get, and these are dollars. How much did it depreciate? It's going to be negative. So negative 5,028.84. So in the first year, it lost $5,028.84 worth of value. Then the next one, you just have to replace that 1 with a 5. Okay, and if your fingers didn't make a mistake there, at the 5th year, it's losing less value per year. And that's like a lot of things. It loses most of its value early in its lifetime. So in the 5th year, it lost only $406 of value. And then C, you just had to graph the tangent line to the function. I'm not going to go over that. Really, it was B that I wanted you to do. All right, that does it for this lecture. Not many left to go. I'll talk to you on the next one.